All right, so let's look at our other example problems that we have. We're going to look at the bottom half of our worksheet. And if you notice on the bottom how it's different now, in addition to just identifying the type of reaction, we have to figure out what is going to go in these question mark spaces here. So let's check out our first one. So we have 7/4 plus an electron. There's only one type of reaction in which that we looked at, in which we're going to have the element plus an electron, and that is going to be in electron capture. So in electron capture, remember, the nucleus absorbs one of its own electrons, and that electron gets attracted to the proton, and the proton changes into a neutron because it had a 1 plus charge, and then it has the 1 minus charge, so then it's going to be neutral, so it's going to be a neutron. In electron capture, remember, electrons have no mass, so the mass number will not change. However, because a proton turns into a neutron, we are going to decrease our atomic number by 1. So before in beryllium we had 4 protons and 3 neutrons to give us a mass number of 7, but now we're going to have 4 neutrons and 3 protons to give us a mass number of 7. And so because the atomic number changed, now we're going to become lithium. So this is what's going to go in for that question mark space right there. Looking at the second one, we notice the same thing. We've got an element plus an electron. So this one is also going to be electron capture. That's the only type that has 2 things in the beginning. So looking at this, once again, our mass does not change because we're trying to figure out what this forms. Because electrons have no mass, the mass does not change. And then if we notice, we have 28 protons, but because that electron is going to get attracted to the protons, we are only now going to have 27 protons, because that proton right here turned into a neutron. So now we are going to have an element number 27, which is cobalt. So both of these are electron capture. How we pick that out right away is the fact that you had the element plus the electron. Element plus the electron. Those are indications of electron capture. Looking at our next example on here. Now we're just starting with just one element. There's nothing else added to it. So therefore we know it can't be electron capture. So let's look at what happened in here. We started with a mass of 217 and we ended with a mass of 213. Right away we know that this has to be alpha decay. The reason for this is because in alpha decay, that's the only one in which the mass number changes. In every other type of radioactive decay, the mass number remains the same. But this one, alpha decay, is the only one in which the mass number changes, and it does decrease by 4 because we lost 2 protons and 2 neutrons from the nucleus. So we know that right here, because this decreased by 4, that means our mass number right here has to be 4. Then looking at what happened to the atomic number decreased by 2, which makes sense because we lost 2 protons, 2. So that's going to be a 2 down there for the atomic number, and we know that atomic number 2 is element helium. So what happened in the alpha decay is that 2 protons and 2 neutrons left the nucleus of actinium and formed the alpha particle, which left, and now the element that was actinium is now francium. So in this question mark here is going to be the 4,2 helium, also known as the alpha particle. All right, so that's what we're going to put right in for that question mark there. Then finally, looking at this last one, we have iodine, and it turns into xenon. So we have 131 as the mass and 131 as the mass. So the mass number does not change. Therefore, we know it can't be alpha decay. So what do we notice happens then? What does change? Well, our atomic number changes, which it does in every single type of reaction, but in this particular one, it increases. This is the only type of reaction in which the atomic number increases, so that would then be beta decay. So in beta decay, the neutron gets rid of a negative charge, and then it turns into a proton. So we go from 53 protons to 54 protons. And because we're changing the atomic number by increasing it by 1, we of course change the new element, and that means we gave off an electron which has a -1 charge, and it also has no mass associated with it because the mass number did not change, and it's just the electron, the beta particle, so therefore we know that this one would have been beta decay because the atomic number actually increased. So what would go in the question mark would be our beta particle, which is symbolized right there.